Next section is the triangle midsegment theorem. We have a new piece of the puzzle, a new segment that we have to talk about. It's not an altitude, it's not a perpendicular bisector, it's not an angle bisector, it's not a median. This time it's called a midsegment. Okay, the midsegment of a triangle is the segment that connects the midpoints of two sides of a triangle. The midsegment of a triangle is the segment that connects two midpoints of a triangle. Midsegment of a triangle is a segment that connects two midpoints of a triangle. And every triangle has three midsegments, and they form something called the midsegment triangle. So here's a midpoint of AB. So midpoint to midpoint is the midsegment. Okay? Midpoint to midpoint, midsegment. Okay? And midpoint to midpoint, midsegment. Okay? That triangle that I just formed with those three midsegments is called the midsegment triangle. Easy peasy? Okay. Now, two properties we want to learn about this. DE is a midsegment of this triangle. Okay? What do you notice about the slopes of DE and AC? They're the same, they're parallel. I love hearing that. Let's verify. Okay? You have to show me that. You can't just say that they're parallel. You have to tell me what their slopes are. Okay, so John, what's the slope of DE? Up 4 over 2? Not quite. Not 4, but 3. Up 3 over 2. Okay? Everybody see how we got that? Okay. So now we want the slope of AC. Up 6 and over, someone said it, 4. Okay? We went up 6 and over 4. Okay? Thought you said they were parallel. If I reduce this, it will be 3/2, won't it? Okay, so they are the same slope. They are parallel. Okay? What else do we notice about the lengths of DE and AC?
DE is like pretty...
We had a prediction of double.
Yeah.
Okay, let's find out. Okay? Chris, how do I find the length of DE? Sure you do. Spinner says you know. James is rooting for you because he's hoping nobody calls on him.
Roasted.
Say it again, Nathan. What did you say? Okay, he says 2 times 2 plus 3 times 3 equals CE times itself. Does everybody agree with him? Okay. How did he know that, or what is he using?
Oh, it's like the slope.
He's finding the hypotenuse, right? So he's using, what's it called, guys? Guy's name, P, starts with P. Pythagorean Theorem. Okay, I'm sorry, you gotta say it louder. Okay? Okay? Gotta say it louder. So 4 plus 9 is my CE squared. So if I take the square root of that, I'll have CE. So the square root of 13 is CE. Everybody okay with that one? Okay. Now we've got to find the slope, or use the slope. It's really a hybrid of a distance formula, right? Use the Pythagorean theorem to figure out what this distance is between C and A. Okay? So 4 squared plus 6 squared, how much? 52. 52 has a perfect square in it. Okay? We did that because we noticed that, hey, I've got a horizontal distance of 4 and a vertical distance of 6 that I figured out for my slope a little bit ago. And so this is a leg of a right triangle, and this is a leg of a right triangle. So there's my hypotenuse. So if I do leg squared plus leg squared, I get my hypotenuse squared. Okay? So yes, we're supposed to remember this. Never forget the Pythagorean theorem.
Can I look up there and say when are we going to actually read this?
Okay. Feel free. Okay? What's the square root of 52? There's a perfect square in it. There's a 4 in it.
4.
Divide 52 by 4. What do you get?
4 point.
Nope.
4.5.
52 divided by 2 is 26. 26 divided by 2 is 13. So this is 2 square roots of 13. So someone who said double before, were they right? Yeah. Square root of 13, 2 times square root of 13. 5, 2 times 5. 8, 2 times 8. 25, 2 times 25. Or if you had 50, you divide by 2 to get the mid-segment's length. Okay? It's not really reflective. It's similar. Yes, it's a dilation. Because we have a angle that's in both, right? And this is the mid-segment. So if this is half, the whole thing is double. If this is half, the whole thing has to be double. Scale factor of 2. Okay? All right. Good connections back to what we learned before. So, we've just figured it out. The segment connecting the midpoints of 2 sides of a triangle, it's both parallel to the third side, and it's half as long as that side. So here's how we would apply it. If anybody thinks that they might be interested in construction, roof trusses use mid-segments all the time. Okay? The architecture in the building that you're in, the roof trusses use mid-segments. Okay? So we have UV, which is a mid-segment. Okay? UV is a mid-segment. It's parallel to RT, correct? So how long is it going to be?
Oh, that'll be 45.
That'll be 45. Why is it 45? 45 is half of 90. Okay? Because I switched them. Okay? Now, VW is 57. Okay. Which one is it parallel to? RUS in the whole triangle, right? So if if VW is 57, how much is SR? 114. How'd you get that? Add them together or double it. Take it times 2. Okay, add 57 to itself or double it. Does everyone see how we'll apply this? This is section 4. Okay, assignment. Book assignment. Nope. You certainly may. Let me pause my video.